Hello everyone, welcome back. In this video we're going to continue working with pandas. So we're going to start off with some standard imports. Import pandas as PD, and it's also going to be nice to have numpy, so we're going to do import numpy as np. Up next, we are going to work with the same Palmer penguins data set. And so we're going to read in the CSV. This is again going to be the same as last time. So we're going to type in pd.read CSV Palmer penguins.csv. Oh, and we should save this CSV in a pandas data frame named penguins. Now, as you already saw, there's a lot of penguins. So we can look at just the top 5 rows, the head of the file, by typing in penguins.head. And now this is just a little bit less overwhelming because there's only 5 rows going from 0 through 4. Now, it is also still kind of a lot to have 17 columns. So we're also going to restrict attention to just 4 columns using the same Boolean indexing trick that we saw last time. So we could say calls is equal to list containing species, region, island, and common length. And so we'll say penguins is equal to penguins calls. So now penguins is just going to be those 4 columns. And let's again use the head function to look at our new penguins file. Alrighty. So now this is much easier to look at. We got 5 rows, we got 4 columns, species, region, island, and common length. If we do want to look at all the penguins, we still can. Now we got all 344, but that's kind of overwhelming, so let's go back to looking at our penguin head. So the simplest way to look at just one row at a time is to use the lock command. So here we can type in penguins.lock 1 through 3. And this is going to give us the first 3 rows. Note that unlike with other indexing procedures, here the endpoint is included. So this is an exception. Now, we might want to also select rows using a list. So we could say rows is going to be equal to, I'm just going to make sure I'm matching my notes so that way the next example works, 1, 4, and 0. And then if we look at S equals penguins.lock, and then we just type in rows, then we can look at S. Oh, and I misspelled penguins. There is an N there. And we see that we have like a sub-data frame only consisting of rows number 1, 4, and 0. A few things that are worth noting is the indexing here is kind of funky. We typed in 1, 4, and 0 here, and so that's the row, the order they appear in on the screen. Another thing is to note that indexing is like a dict. So there is a row with index 4, so this will work. Sorry, s.lock 4. Got to use the lock. However, if we try to just access the entry in row 2, that's not going to work. Even though there are 3 data frames, so normally you'd think index 2 is going to be well defined, it gives me a key error because it's like a dictionary and there's no key corresponding to the number 2. So this is how you can extract rows using explicitly the row numbers. But a lot of the time, this is not quite the way to go. And to think about why this isn't really the way to go, let's look at our penguin data set, the old big thing, which looks like this. We got 344 rows, and the order is kind of irrelevant in this context. It's not like penguin 3 is the penguin that's like the father of penguin 4 or some nonsense like that. The order is kind of arbitrary. But instead, what we might want to do is we might want to look at what are just the penguins who live on Island Torgenson, or what are just the penguins that have a long culmen. So to do this, the tool we want is to use Boolean indexing. So let's go ahead and create a mask that's going to let us restrict attention to penguins with small culmens. So we could say culmen mask is equal to penguins culmen length in millimeters being less than 40. So what we're doing is we are looking at penguins length culmen in millimeters is a NumPy series, which is, a Pandas series, which is effectively the same thing as a NumPy array. We are pointwise comparing it to the number of 40. So this, actually, if we just look at this by itself, this is going to give us a list of trues and falses. And so now what we're going to do is we're going to restrict attention to the penguins where the mask is true by saying penguins, and then input as an entry culmen mask. And now we get a subdata frame where we only have the penguins with short beaks, culmen length less than 44 millimeters. Alternatively, we can try to restrict to penguins just living on the island Torgeson. So we can say island mask is equal to penguins island equal Torgerson. And let's go take a look at our island mask to make sure that I spelled Torgerson correctly. Hooray, I did. Actually quite impressed with myself. Torgerson is very hard to spell. Okay, so now we can restrict attention to just our Torgerson penguins by typing in penguins island mask. All right, so now we have another subdata frame where we're just looking at the penguins on Island Torgerson. So lastly, or not lastly, but nextly, we should try to use and or. So we can get penguins which are both have small beaks and are on Torgerson, or we could also use or. So to do that, we use the bitwise and operator. So we say penguins culmen mask bitwise and, it's important to use the bitwise and operator, and island mask. And I'm hoping my capitalization is correct. Did I call it capital island mask up above? Let's see. Yep. Sorry, I lost track of my uppercase, lowercase. I probably should have called it lowercase island mask all along to be consistent with culmen mask. But anyways, here are the penguins which live on Torgerson and have short beaks. Well, you can see there's 130 of them. Similarly, we can use the or with the bitwise or operator. So we could say penguins culmen mask or island mask. And I forgot the S in penguins. And so now we can see that there's 150 penguins with small beaks that live on, that either have small beaks or live on Torgerson, and that some of these penguins also live on Dream. So this is so far very useful, but perhaps the most useful application for Boolean indexing is getting rid of nans, not of numbers. Earlier, we saw that there was 344 rows in the columns, and only 342 of them had valid numerical input in their Kalman length. Now, if we're trying to do data analysis, these not a numbers could cause all sorts of problems. So let's try to throw them away. So we're going to say nans is equal to penguins, Kalman length, millimeters, dot is NA. Is NA is going to restrict attention to where the data is a nan. So we see there's two rows with a missing Kalman length, row 3 and row 339. Now finding the nans is good, but what is better is getting rid of them. So for this, we're going to have to use the NP invert function. So we do penguins is equal to penguins np.invert nans. np.invert changes true to false and false to true. And now we are overwriting our original data frame by saying penguins is equal to the penguins where the nans aren't. And now we can look at penguins.shape. And we see that now our penguins data frame only has 342 rows, and we've thrown away the 2 bad rows. So that's it for this video. I will see you guys again next time.